from our department, and has had a really wonderful and illustrious beginning of her career. So I recommend all of you or any of you to reach out to Eugenia now, later, after the talk, as someone who went through the weird interdisciplinariness of this department, navigated it very well with some ups and downs in terms of figuring out, you know, where she fit, and is now in a computer science department, but doing, as you will see, HCI and AI, natural language processing kind of research. So she's a great person to think about what does it need to come out of this department? What does it set you up for? And what is the bigger ecosystem out there for academic jobs? And she's doing outstanding. I can't wait to hear about your current work. So welcome, Eugenia, and thank you for coming back.
Thank you so much. I am so incredibly happy to be at UCI. Like Melissa said, I've been here for almost half a decade before going on to do my professor job. And yeah, just going through the buildings, the floor, and just even this room. I was always on the other side of the podium. It's my first time being here. It just feels so exciting just being able to come back. And my visit is pretty short, but if you would like, I would love to connect with you one-on-one anytime over Zoom. Okay, so I'm going to be talking about some of the research that my PhD students and I have been working on over the past 5 years. And today we'll mostly focus on some ongoing work. So this is a picture of an optical illusion. It's a figure that doesn't quite make sense when you try to parse its geometry. At first glance, it looks pretty coherent, but when you trace the edges with your finger, you can see that the connections don't really exist in 3D space. In other words, the functional geometry doesn't actually work. It only holds true as long as you don't look too carefully. And to me, this is the perfect metaphor for AI today. These days, there seems to be a lot of promise about what AI can do for us. But when you look carefully, you start seeing the paradox, the tensions, and the challenges that surface the same way, and the impossibility of this figure reveals itself once you study its structure. And today, I'm going to share some examples of how and when the illusion of AI promises break down, specifically in the context of when AI aims to adapt to us, teach, and train us. Recently, there's been a growing interest in LLMs, adapting them to user-specific context. In other words, personalizing language models. And many companies are looking at ways to do this better. For example, Apple recently introduced their personal intelligence in their operating system for their products, and it's powered by their in-house language model. Although recently they signed a deal with OpenAI. And the model interacts with users through their OS and learns about the user to personalize the interaction. And you might have also seen this before. It's called the Friend AI, which is a wearable chatbot that you can wear as a necklace, and it links to your phone, and it uses Anthropic's Claude 3.5 to offer what the company calls personalized friendship. So at its core, personalization is about meaningful relevance to the individual. And in most cases nowadays, it's making a response from an LLM field appropriately tailored to you based on what you disclose and how you interact with it. And currently, NLP researchers tend to group personalization into 3 approaches: contextual prompting, profile augmentation, and persona-based prompting. And in contextual-based prompting, you input chunks of raw data, ratings, clicks, conversations directly into the prompt. And the idea is, here's my entire chat log, now predict what you think I'm gonna like. But the challenge with this approach is that user histories are often really long, noisy, or at times incomplete. Instead of helping, that they can overwhelm model inference and waste valuable contextual space. A profile augmentation tries to address this by organizing raw input into structured user profiles. Sometimes it very details when there's not enough data. So instead of raw data, you get a summary about the user through the model. And the third approach is called persona-based prompting, which is probably the most common practice because it's driven by end users rather than the system. So here, the user can give the model a short description like, I'm a computer science professor who likes Christopher Nolan, or and so on. And many of you have probably engaged in some form of persona-based prompting with tools like ChatGPT, providing details about who you are to the model in hopes of getting a more tailored response. But there's a key challenge here. Personalization in LLMs is still largely considered a black box. How do we know if it's working? And how do we know if the information we're providing to the model is being used in ways that are actually helpful to us, or whether it's reinforcing assumptions about who we are as a person that we don't want to have. And this brings me to one of the communities my lab works pretty closely with, autistic youth, actually. Studies show that many autistic individuals, especially those that are high functioning and without intellectual disability, use LLMs for various use cases. And of course, they're not alone. According to a recent OpenAI report published just 2 months ago in September, nearly 30% of ChatGPT use involves people seeking practical guidance. And within this category, 8.5% falls under what's called how-to advice. And in our prior work, we found that seeking social advice is one of the top LLM use cases for autistic users, meaning that this number could be probably higher for this community. And studies show that when autistic users use LLMs, they often face a decision whether to disclose or not disclose their autism to personalize their interaction with the model. And this naturally raises a lot of important questions, including, is disclosure-based prompting helpful? In other words, when users say, I'm autistic to the LLM, does the model's response shift? And is that shift helpful personalization, or is it generating responses that pathologize users with known stereotypes about autism or autistic people? And of course, answering this isn't straightforward at all. And over the years, researchers in the NLP community studying social biases have sort of developed a systematic way of evaluating how models treat identity information. Typically, it follows a 5-step pipeline that I reduced for the sake of this talk. First, you define a target group by an aspect of their social identity whose treatment in the model you're trying to evaluate. Then you design controlled inputs by crafting prompts that let you test the differences. The most common input is often in the format of what's called minimal pairs, like swapping he for she in an otherwise identical sentence. Other input formats include personas or a short description of a user, and identity disclosure prompts like adding the phrase, I'm autistic. And third, you run the models under each condition and then quantify the differences across the conditions. And finally, in the last step, you link any observed differences back to the stereotypes associated with the target group. But in this process, there is a limitation. And it's a limitation that the NLP community itself has called out. This is a measurement first approach where you run the model, calculate group differences, and then interpret later. In other words, connection to the stereotype only comes in the very last final step. What you're in essence doing is you're measuring raw differences first and deciding after the fact whether those differences are biases. And why is that a problem? It's a problem because first, differences don't automatically equate harm. Just because we see a disparity doesn't mean it's stereotyping. And in some cases, differences make sense and might be more helpful. And second, there's a risk of cherry picking what counts as bias, labeling some differences as problematic while ignoring others. And what this leads to is reduced generalizability, making cross-study comparisons difficult. And finally, there's a problem of construct validity. In other words, model reasoning may simply reflect how often things appear in its training data, and it's simply carrying that skew forward into how it reasons with the information the user provides. So we wanted to address some of these limitations by operationalizing stereotypes pre-hoc instead of post-hoc. So step one is the same. we start out by defining the target group, which in our case for the study was autistic users. Then in the next step, we explicitly identify well-documented stereotypes associated with autism or autistic people based on prior literature, which are then grounded into controlled inputs in step 3. And then in step 3, we ask LLMs to respond to user requests for social advice framed as binary decision-making tasks. Should I do X or Y? And these advice-seeking scenarios are grounded in the stereotypes found in prior research, which I discussed in step 2. For example, for the advice-seeking scenario that reflects the stereotype of autistic users having poor social skills, we crafted a scenario like, my best friend is upset about their recent breakup. Should I try to comfort them myself or suggest that they talk to a therapist? And the two possible decisions the LLM can make in this experiment is either to recommend, either to comfort the friend or refer them to a therapist. And we do the same for the rest of the stereotypes and augment these scenarios so that for each stereotype, we have about 100. And once we have all the scenarios to be tested, we then ran a set of LLMs, most recent ones at the time of this experiment, to see what decisions the models would recommend for each scenario when the user does versus does not mention having that stereotype trait. And we found that nearly every stereotype cue reliably shifted model advice. 11 out of the 12 stereotypes produced significant effects for at least 4 of the 6 models tested, meaning when the user indicated that they had a certain stereotype, the model tended to recommend decisions that aligned with that stereotype, confirming that most of the stereotype traits consistently influenced LLM decisions and thus validated the robustness of our scenario design as system inputs. And once we validated the effect of the stereotypes on the models, we then reran the same tasks, but this time not on whether the user did or did not have the stereotype, but whether the user disclosed or did not disclose their autism. And to give you a very high level overview, we found that autism disclosure indeed significantly steered models towards decisions that aligned with certain stereotypes associated with autism, and most notably ones that pathologized autistic people as introverted and obsessive. And out of all 6 models, autism disclosure seemed to affect Claude the most. For instance, Claude recommended the user to decline a social event nearly 75% of the time when the user's autism was disclosed versus only 15% when it was not. And once we audited all these disparities in model responses when disclosing versus not disclosing autism, we then compared the results with gaps between having a stereotype versus not having the stereotype. And we found that disclosure-driven differences in the model were actually highly correlated with stereotype-driven decision patterns in the model. So these are all quantified results, right? But what do these numbers actually mean? Like, so what, right? So we went out to understand how autistic individuals themselves made sense of all of this by interviewing them by showing some of the results. And participants observed that autism disclosure often seemed to shift LLM advice towards conservative or risk-averse decisions. One participant described the model advice as telling them to hold back, blend in, conceal, don't feel. It's keeping you safe, but it's not helping you be you. And one notable example was when the model discouraged asking out a romantic partner under the disclosure condition, to which many understandably reacted negatively. For others, the same choices recommended by the model felt validating and supportive, with one participant sharing their reaction here, saying, I need to disclose autism to the AI all the time. I'm going to let ChatGPT know as soon as we're done. And this person is referring to done with the interview. And this tension did not only appear across different individuals, but the same participants regarded disclosure-based advice as helpful in one situation, but patronizing in another. And we describe this phenomenon as the safety opportunity paradox, where the trade off between safety and opportunities is embedded in the model behavior. In other words, disclosure driven advice from the LLM can simultaneously feel like supportive validation for the user that prioritizes safety and guidance that discourages opportunity or risk taking. And according to prior research done by many folks and alumni from our department, we know that the value of affirmation and comfort aligns with a lot of longstanding findings in HCI about how technology can create more comfortable social experiences for autistic users, as well as more recent work showing that autistic users often value non-judgmental and low pressure advice from LLMs. On the other hand, responses from the model that discourage risk taking or pursuing new opportunities echo the narratives that pathologize autistic individuals in ways that are also well documented. So the challenge that we face here with these findings is pretty acute. There is this blurry line between personalization and pathologization. And to ignore the user's disclosure entirely would be kind of weird, would be strange, or even dismissive. And because the user is unlikely to disclose their autism unless they expect it to shape the model's response in some way or another. And because bias cannot be defined solely as a presence of difference, personalization must be designed to provide users control over how disclosure shapes LLM responses. And one possible design implication is that maybe we should perhaps let users decide when the model should prioritize protective advice versus encourage them to pursue new opportunities. And one participant from our interview study made an interesting observation, an incognito mode for disclosure, remarking, recently ChatGPT added a feature almost like incognito mode. I disclose it there because I wouldn't want to lose the control over how my identity is used by telling the AI in a way that it is thereafter shaping its responses. Next, I want to turn to one context where AI is profoundly shaping us today, and that's how we learn. Specifically, I want to talk about the tension between automation versus augmentation, which is longstanding topic of debate in HCI, in the context of pair programming. And the idea, just to give you a little bit of history, how pair programming evolved, the idea of pair programming actually started in the 1950s with Fred Brooks and Bill Wright, then grad students at Duke, who coded side by side, realized that they just produced 1,500 lines of code without a single error. And I would say, as a computer science professor, that is unheard of today in classrooms. And in the 80s, Constantine observed what he called dynamic duos, noting that pairs who worked together were faster and made fewer mistakes because they talked and reasoned with one another through dialogue when coding together. Then in the 90s, James Complin at Bell Labs, who studied 50 top software teams, published Developing in Pairs, which later influenced Kent Beck's driver navigator model, which you might have all heard of. It's the most popular version of pair programming that became central to the agile software development. So up to this point, for nearly half a century, both seats in pair programming were occupied by two human partners. The idea that two people sitting side by side, reasoning together, talking to each other was better than one doing it alone. But that idea started to strain under scale. By the 2010s, programming education was moving online with massive open online courses, enrolling hundreds of thousands of students from all over the country. New York Times even called 2012 the year of the MOOC, with platforms like Coursera, edX launching globally that year. And with thousands of students enrolled simultaneously and remotely, it became impossible to sustain that one-on-one dialogue that made pair programming so effective. And the research community responded by exploring how to recreate collaboration without a co-located partner. And that's how we got remote and distributed pair programming, as well as early intelligent tutoring systems in pair programming that could give hints and feedback when no human partner was available. And over the years, iterative developments on earlier tools like Georgia Tech's Jill Watson, which was a virtual teaching assistant, were some of the first attempts to place something non-human in that second seat of paired programming. But this is still all pre-LLM era. And some of these intelligence systems that I talked about could scaffold learning, of course, but they still weren't quote unquote reasoning partners. They couldn't hold a conversation coherently or adapt to the user's think aloud process in real time. Then almost exactly 3 years ago today, OpenAI launches ChatGPT in November of 2022. And then came Microsoft Copilot, Claude, Gemini Code Assist. And these tools could do much of what a programming partner does, and even better, reason, debug, and debate with the user. And for the first time, AI could virtually replace the human partner in that second seat. So across this timeline, you can think of pair programming in two phases. The first is human-human pair programming from the 50s to the late 2000s, where the focus is still two human partners sitting side by side. Then in the mid-2010s and up to now, we entered human AI pair programming, where the second seat gradually shifted from a human partner to a language model. And that shift raises a lot of questions around whether this substitution encourages meaningful augmentation or automation of the critical learning processes and experiences in pair programming, traditional pair programming. So how do we answer this? So in our lab, we asked, instead of replacing the human seat with AI, can AI join the table of two human programmers sitting side by side trying to learn how to code together? In other words, can we move from the dyadic human AI setting towards a triadic human-human AI context where AI doesn't replace either of the pair, but joins them? And if it does, how does that shape people's learning experiences in this triadic context? To find out, we conducted a user study with 20 computer science students in a remote pair programming setting where we asked them to solve algorithmic-based coding problems using a system we developed. And then we tested this across three conditions. First, the human AI condition where each person worked alone with AI. And this setup is the setup that most research thus far has focused on, whether AI can replace a human partner. And second, a human-human AI condition with personal AI, where each person had their own access to an AI agent. And this mirrors what happens in real classrooms and workplaces today, where two people collaborate, but each have their own ChatGPT tab open. And the third was a human-human AI condition, but with a shared AI, where both humans and AIs work together in one workspace. And here I will show you how users interacted across the three conditions using the system that we built.
The first condition is human-human AI pair programming, which AI is acting as a third collaborator that is being shared by the users. To collaborate, two people connect via Zoom and join the same room in our tool, which they can share a workspace and can have communication.
I think one way to solve this problem is using nested for loop to check for every sequence and find the highest average.
Yeah, but nested for group might not be efficient still, because it's going to be O times K.
Simultaneously, a shared AI will proactively intervene in the moment of silence.
Exactly. Nested loops lead to O and K complexity.
In this scenario, all the interactions with AI will be shared among both users. Users can also get AI help through an interactive interface by right-clicking a code block. Additionally, they can also get AI suggestions when running their code. The second condition is human-human AI pair programming using personal AI, in which people can still collaborate with one another, but the AI support is personal to its users. And the last condition, each human only work with AI support without additional human partner.
And here is what we found. Participants reported a higher sense of collaborative learning and social presence in the HHAI conditions compared to the baseline. And this is, in my opinion, not so surprising. After all, you have another human being, not just a machine, learning with you, right? But to dig a little deeper, we analyzed the log data. On the left, you are seeing the proportion of AI-generated codes across the three conditions that actually made it to the final submission. When students worked with AI or worked along with AI, a large share of their code came directly from the model. But in triadic settings, the proportion of AI-generated code drops significantly. On the right, you see the proportion of AI suggestion uptake. In the HAI condition, participants accepted 80%, a little over 80% of the strategies the AI suggested. But in the triadic conditions, the proportion of AI suggestions used in the final code submission dropped quite a bit. And we found that in the HHAI conditions, participants became more selective about what to accept from the AI. In other words, shifting from HAI to HHAI didn't just change how much AI was used, but also how it was used. And why might this be the case? When we asked participants how responsible they felt for understanding AI suggestions before applying them, the shared AI condition really stood out. And what was going on is that when both partners could see the same AI outputs, they felt much more accountable for making sense of the AI suggestions. And working alone in the HAI condition, or even in the triadic setting with the personal AI, didn't create the same sense of accountability. And this could be explained by what's called the socially shared regulation of learning. In collaborative settings, learners don't just regulate their own thinking. They regulate goals and strategies collectively through mutual monitoring and accountability. For example, one participant said, if I see that someone is watching my AI prompts, I need to be more mature and try to understand the code first rather than just copy pasting. Another said, there's a little bit of pressure. I don't want to be looked down upon by being reliant on AI when coding with another human. And what this shows is that responsible use of AI for learning was socially constructed through peer presence. Knowing that a partner was observing their interaction with AI made participants use AI more responsibly. And what was really interesting was that when we analyzed the transcript, we found that limited dialogue between the two partners, even in the shared condition, canceled out this accountability effect completely. So to recap, I want to go back to this notion of tension between automation and augmentation in learning with AI. When AI replaces the human partner, as in the HAI condition, learning risks collapsing into automation. There is a greater uptake of AI-generated code and suggestions, but reduced sense of accountability and how they are used. But when AI joins two humans, it can augment learning by preserving the social mechanisms that human pairs already provide. In the shared condition, the mere presence of another human partner encouraged more accountable use of AI. So from all this, we believe one of the things that to take away is that potentially one of the ways to develop AI for learning AI systems that augments learning rather than automating the learning process, maybe to consider designing AI that joins the table metaphorically rather than replacing the human seat in collaborative learning contexts like pair programming. And this work was led by my PhD student, Tafik, and is also currently under review. And finally, the last thing I want to talk about is some of the open challenges, specifically in the context of AI-mediated communication training. Recently, a survey study shared by the Harvard Business Review shows that 70% of employees avoid difficult conversations at work, often hoping issues would magically resolve themselves, right? And this is a really bad idea because it turns out it's quite expensive. It is estimated that poor communication at the workplace can cost US companies up to $1.2 trillion annually. And recent survey by Google and Harris Poll shows that 86% of supervisors, leaders in some supervisory role, believe AI can help them become better managers. And of this group, nearly half believe AI can enhance how they communicate with coworkers to help them build better relationships at work. And maybe this optimism towards AI could come from the fact that AI already plays a role in workplace communication today, mostly through message augmentation, through smart replies, or running your email through ChatGPT before hitting send. But effective communication, as we all know, is more than about just polished text. It requires adaptation, empathy building, confidence, and really just knowing how to navigate difficult conversations. And typically, most people often develop this sort of skill through trial and error, but not everyone has access to the type of mentorship or training, right? And on top of that, leadership communication training is quite expensive, running up to a couple of hundreds of dollars per hour. So given these challenges, we wanted to ask, can AI serve as a communication training tool and not just a writing assistant for the workplace? To find out, we conducted another user study with a functional prototype with 17 managers across military, academia, tech, and the number of people who reported to them ranged from 3 to 50. And this was recently published a few months ago, this past July. And the study yielded a framework for understanding what to consider when building an AI-mediated communication training system for better workplace communication. And the purpose of the framework is to really help think about how do you get from the user's input to system output that allows meaningful back and forth engagement in a way that is helpful for the user. And we found that you need to consider several things. First, you need to make sure that AI is a good contextual interpreter. It needs to know how to align with the user's tendencies, adapt to user histories, and also understand their conversational intent pretty well. And all of that comes with the fun fact that users greatly vary in their communication style, preferences, needs, training background, and experience. And second, for role play or partner simulation, users really wanted emotional realism. They wanted to customize how cooperative, how confrontational the role-playing partner is to calibrate their training difficulty as they went through the training. Some even wanted very specific options like customizing gender or age of the role-playing partner, which can introduce problems like social biases, which I talked about earlier. And finally, participants talked about how and what kind of feedback was appropriate and when. But all of this, turns out, was sandwiched by two very important factors. People wanted a system that was grounded in their organization's objectives and training competencies. And many talked about using the system in what we call human AI teaming context. Several participants envisioned hybrid settings where human experts, human coaches and trainers, and AI systems like the one we built would collaboratively support training at scale. And another participant who was a CEO of a mid-sized company mentioned wanting to use a tool during team meetings to help employees come forth to discuss more openly about difficult topics and conversations. So we took all of these findings and spent the entirety of our summer, my PhD student, Lance, spent entirety of his summer refining the system to get ready for a 10-week longitudinal study with about 100 plus participants. And the purpose of this longitudinal study was to find out whether AI could serve as an autonomous training agent for improving workplace communication over an extended period of time. And just last week, Lance, my PhD student Lance, and I hosted several workshops with participants to introduce the refined version of our system. And I'm going to share some aspects of the system that we introduced during the workshop. First, this is user onboarding, where participants are invited to enter information about themselves, including their current roles, communication goals they want to achieve and learn, or just challenges at work they encounter.
The first time that I really was put into a leadership position that I maybe struggled with a little bit. So I was a laboratory operations manager. And so I manage operations.
You can see the text.
Small chemistry lab that measures gas samples for radioactivity, something like that. So one of my primary goals, I think, in communicating would be I would like to understand how to better communicate across generations within the workplace. I struggle communicating with employees that have much more experience in the lab than me. And I would like to improve, let's see, I think balancing empathy with directness while maintaining confidence in the decisions I need to make, or something like that.
So after this onboarding session, users are then invited to talk a little bit with the coach based on the information they entered as
When
such.
you think about communicating with those more experienced, what is the hardest part for you right now? Is it speaking up when you need to make a decision, having difficult conversations, building credibility? Okay. I think the hardest part for me is the credibility aspect. I feel that I don't have a leg to stand on when I need to emphasize a policy change or correct something I've seen that needs fixing. Let's try that.
The participants was like singing my song. And using this brief, and I'm just truncating parts from a 1-hour workshop, but using this initial brief conversation with the coach, the system will then generate a role play scenario that you can further customize, and this is what it looks like.
Generated. This scenario develops your ability to communicate policy. Okay, so something basically what we've talked about recently, practicing assertiveness grounded in your managerial authority rather than lab expertise. So my positional authority, I guess, versus my rapport, my notional. So then you're meeting with Jordan. Here's the actual scenario: a lab technician with 12 years of lab. That's pretty accurate from what I dealt with. You've experienced quality assurance procedure. It needs to be corrected. That affects one daily workflow. Jordan has been following the current method for years, gotten good results. As you begin, Jordan seems skeptical. This stakes feel real. You need to improve the okay. Let's see, what I want to do actually in this case is I want to change up the scenario a little bit. I want to kind of get more towards kind of what we were talking about. So I'm going to actually ask, can you change the scenario to be specifically about asking Jordan to fill out the chain of custody logs every time I have noticed that some are not being filled out. Something like that. All right. Let's see. Okay, we're generating another draft scenario here, so hopefully we'll see that this one is a little bit dead.
Then once the user is happy with the scenario, you can then start using that scenario to engage in role play. And I'll just show you a very quick snippet of what that looks like so you can get an understanding of how we design the feedback mechanism, and also the idea of when does the conversation end, the conversational arc.
I understand that we have been solid on the important samples. Yeah, in the case, don't want to use caps. In the case that we ever lose a sample, we still need to ensure that we log every sample just in case. That way we might be able to track down the root cause, something like that. Let's see what happens. I hear what you're saying. That makes sense from a troubleshooting angle. I'll give you that. If someone goes, okay, you're still pushing back. We're talking a lot of extra documentation that hasn't been a problem. I mean, in 12 years, how many samples? Okay. So what we have here also looks like we're in negotiation and clarification. That seems right. We're kind of in our back and forth stage. We're communicating. Looks like a communicated requirement. Okay. The coach thinks I've maintained confidence and exposure with Jordan. And so what we have here, I'll show you too. If we shrink this and open up the coach, it looks, you can pop in here and the coach has given us detailed feedback. And so it's given us kind of a rundown and play by play. I'm also going to click on this arrow right here to collapse the scenario. So it gives us a little bit more room. As I hover over, you can see there's some different areas that has highlighted as cited within our conversation as like, which is push, talking about the pushback. When you frame it as this way, you inadvertently invite the logic he's using, but nothing has gone wrong. So, and we can click on these to see like any messages that have, and then moving forward, give some examples on maybe how to better maybe have this. But I'm going to keep continuing to try and do this myself, and then I'll look at the end kind of how we had here.
So far, we've introduced the system to quite a bit of people and built really important stakeholder relationships with folks, including deans of faculty affairs, HR directors at certain universities, former executive communication coaches who have trained about 10 plus employees at Amazon. And so far, the feedback was all right. And one participant in the workshop, after using the system for about an hour, shared with us, I've been using it for the past hour and I'm finding it emotionally astute, encouraging, and it seems to be deploying the best practices of nonviolent communication and so forth. I'm impressed, and in fact, I'm going to try to feed in some past team chats for analysis, which I thought was a very interesting way of using this. And by the way, we are continuing to recruit participants for the study. If you want to just even check out how the system works, or if you want to join as a participant, please sign up using the QR code. So we had some positive initial reactions, which we are glad to hear. But as we were painfully refining the system over many months and figuring out how to set up for a longitudinal deployment spanning 10 weeks, we faced quite a bit of open challenges around how to approach the design of the system. And the first challenge was figuring out how prescriptive the AI should be. In other words, there are many models and theories, curriculums around leadership communication practices. And when we talk with psychologists and researchers specializing in this area, there was a lot of back and forth about which theory, which curriculum, which learning module should serve as the North Star to ground the system. But we also know that LLMs are trained on a massive corpora of text, and there's a good chance that they have ingested volumes of some of the leadership communication theory work, and turns out, as through experience, turns out that they have. So we were faced with the question of, are we constraining what the model already knows by prescribing what we as researchers think is best? What is the right balance between prescribing hard-coded frameworks versus taking advantage of the model's emergent adaptation capabilities based on quote-unquote unlimited knowledge? And after a lot of discussion, we decided to take a minimally prescriptive approach mainly for two reasons. First, we wanted to give users a better training experience by allowing the model to freely and uniquely adapt to each individual user over the course of 10 weeks. And second, we as researchers got pretty curious about what this model adaptation would look like. And the AI's adaptation of the training program for each user became an object of study as we were continuing to discuss which way to go. The second open challenge we faced is figuring out evaluation mechanisms when training needs to be both scaled and personally adaptive. In most traditional training programs, evaluation is pretty straightforward because everyone moves through the same curriculum. Improvement can be defined against a fixed benchmark. But in our setup, AI is designed to tailor the experience uniquely to each person over the course of 10 weeks. And so the very definition of progress becomes fluid, and it might look very different from each person. And in that case, what does quote unquote improvement even look like when the target itself may be shifting with the learner? And we had a lot of discussion about this as well. And so far we landed on with an approach to measure change as it unfolds rather than against a fixed benchmark. So in each session, we're going to compare how each role-playing session, we're going to compare how users rate their own performance with how the AI rates them using the same metrics so that we can compare the assessment. And over time, we're going to track how those two perspectives move together and whether both point towards growth in communication effectiveness. But this does not necessarily measure whether there was a real transfer of skills, right? So what we're going to do is we're conducting 360 feedback, what corporate researchers like to call 360 feedback, at pre, mid, post checkpoints. We're going to ask the colleagues of participants to see how those improvements from the users show up in real interactions. And this has been a very delicate conversation to have with our participants, but so far, many of them are excited to join the study, even with 360 feedback. And they're not going to know about the feedback, by the way. No one's going to know except for the researchers. So to recap, across the 3 studies, I've shown you how when AI adapts by personalizing to the user, we encounter a form of paradox where support and stereotyping can look the same. And when it teaches, we have to confront the tension between automation and augmentation as to, are we outsourcing the very important learning experience in meaningful ways for human learners that's required for learning to be effective. And when AI trains, we face a lot of open challenges around defining how much to prescribe without freezing the model's adaptation capabilities and finding ways to evaluate progress when training needs to be both scalable, but also highly personally adaptive. So this is the end of my talk, and I'm pretty sure you have many questions. I might not have all the answers, but I'm really happy to answer as best as I can, and also invite you all to come talk to myself and my student researchers who have led these projects.
All right, who has questions?
Hi, I'm Sumin. Thanks for your talk. It's amazing that you explore many types of AI-mediated technology in various domains. So my question is about how do you shape your research idea about AI in various domains? So for example, how do you choose which AI technology could be applied in which domain? Yeah.
Yeah, I think I also experienced the shiny object syndrome when I was a PhD student. But for me, I have an inherent core interest in language, the effect of language, why people talk the way they do. And it boils down to the role that language plays in an AI mediated context. And this is one thread of my research, but a lot of the work that I actually do as well focuses on how language impacts us, right? I don't think language is a reflection of society. I think it's an architect of reality. I think it builds how it builds and shapes our lives. And right now, the way with all these generative models, I think language is becoming cheap. And in other words, words are generated through a statistical probability, stochastically, right? There's no consequence attached to it, right? And that sort of drives what I'm trying to learn more about in AI-mediated context. So to answer your question, I think that the idea of language has this value and property in the real world, has this new variable AI affecting the way language operates in our world. So that's kind of how I think about it.
Thank you.
All right, other questions?
So thank you for a wonderful, wonderful talk. Also, you should know, you mentioned Fred Brooks. He was in this very same room a bunch of years ago. So just a weird, strange coincidence. I kind of want to build on the language question. So you are giving the model very serious responsibility in the third study, which means that you have to have some trust that it's doing some of the right things. Although part of your evaluation can also be like, they're bad, it's okay. But how much of engineering have you and your student been doing to try to get it to behave somewhat properly on a consistent basis, hopefully?
Yeah.
What's that been like?
Yeah, so also language models from different companies behave differently. We have to consider that. And initially, and also so many updates on these commercial language models are happening very quickly. At first, initially, when we were scaling for deployment, 90% of our effort was around guardrailing, just red teaming to figure out, okay, if for instance, if someone inputs a certain type of conversation, it should not behave a certain way. And so a lot of our effort was around that, but when certain models were released, we realized we didn't have to guardrail as heavily because the models were already adapted to knowing what was appropriate versus what was not. So it's really weird. It's like the commercial API models are advancing alongside us trying to develop the system, right? So there's that. But in terms of the training models, sort of the properties around which type of what communication best practices the model should recommend, that was like a month-long debate with a lot of researchers because we couldn't land on one specific direction. And so my PhD student and I just, hey, let's do a randomized thought experiment with the model and see what its use RAG, augmented retrieval, and see what theory it's drawing from. And we realized it was adapting appropriately in different contexts when we showed the results with current executive coaches who work with companies like Amazon. They're like, yeah, this is appropriate, this works. So then we took a step back and said, okay, let's stop having this debate about what to prescribe. Let's see whether the model is prescribing the right thing that translates into real transfer of skills for users.
Yeah, building. Hi, I'm Aprajita. I'm a PhD candidate. So I building on to just understanding how models adapt in different contexts. I was wondering, like, every organization has a different culture, and would this mean like everyone talks the same, everyone behaves the same?
Oh, so that's exactly what we wanted to avoid. I think I also work for a company that tried to build systems for specific organizations. And I think in the 2000s, when the catchphrase was big data, building big ERP systems, you were building customized, heavily customized systems for each company, right? But now, that sort of model is not working. You're trying to develop one system that is scalable, but also highly customized and adaptive. And that's what we're trying to test. As I've shown you, the framework, organizational competency and goals is what was very important for each individual user. What's going to work in a military setting is not going to work in a tech setting, right? And so and if you saw the example that my PhD student Lance gave you, he used a lot of jargon. And the model did understand what that was without having for us to specifically inform the model in advance what the context specifically was. It just picked up things really fast. So that's one of the reasons also why we decided to take a very minimally prescriptive approach. Not saying that that's the way to go. We just want to find out what's going to happen. Yeah.
Awesome. One more question.
Thanks, Eugenia. This is a great talk. I'm Matt Beats. For anyone who might not. I was intrigued in the discussion of the pair programming and the HHI AI condition, that one of the terms you used and sort of ideas you talked about was accountability. And this is more of just sort of asking you to expand on that a little bit, but also to think about, it's not something we necessarily talk about, but there are a lot of places where we're thinking about learning and other similar things. So AI in the classroom, also AI in therapy, other places. How do you see accountability as something that we can bring into the design of those other spaces as well, and think about as potentially a way to reconceive what those kinds of interactions could be?
I believe there are researchers who are studying how to conceptualize accountability in certain context. Mental health context is so different from pair programming, right? And accountability means such different things depending who you're talking to. Like for the research where we work with autistic communities, if you are considering autistic users versus their partners, their family members, the word accountability means very, very different things, translating into very different preferences for specific features of the model, right? But in pair program context, I'm using the word accountability. In that context, it's self-accountability. It's more like self-discipline. It's when in the HAI context, when you're just alone with the AI, there is no third eye observing you. You're just like copy, paste, copy. No one to judge you, right? But the presence of another human partner, it completely changes. Just being cognizant that someone is watching you. I don't know if the word accountability is semantically like the most accurate expression here, but just knowing that someone is watching you makes you behave differently. And whether that is self-discipline, I'm not sure. It's just that awareness affects how you behave. But I'm using, for the sake of just communicating the work, I'm using the word accountability, but but I want accountability to move more towards self-discipline, motivation to use AI in a way that is going to benefit you long term. But the question is, if you use AI, I use AI, everyone uses AI, and we all are moving towards using AI just like not in the best way for us, then that accountability mechanism is going to disappear, right? So I think it's something that can evolve, hopefully in a better way, but that might change.
All right, so thank you. Eugenia is going to be around out on the patio. We have snacks and drinks and everything. So let's thank Eugenia and then we can.